Looking to enhance the performance and reliability of your stateful applications on GKE? Well, we've got fantastic news for you. With the seamless integration of NetApp Trident CSI Provisioner and Google Cloud NetApp Volumes, you can now unlock a whole new level of dependable, high-performance storage for your stateful Kubernetes applications. I'm Diane Patton, a technical marketing engineer from NetApp, and I will show you how. This is the demo that we have set up today, where we have start with a GKE standard cluster. We will create two different storage pools, one with the Flex service level and one with the Premium service level. Next, we'll install Trident and install two Kubernetes applications. One of those apps uses the Flex storage pool, and the other will use the Premium storage pool. And last but not least, we'll take a snapshot of our volume. So let's get started. We are starting on the Google Cloud Console, where we have a standard Kubernetes cluster in US Central 1A called GKE NetApp Volumes. We can see it's a zonal cluster, and there are 3 nodes in the cluster for this demo. Next, let's create 2 storage pools on Google Cloud NetApp Volumes for our Kubernetes cluster to use. Hit Create a Storage Pool, give it a name, select a location. Now remember, 4 service levels are supported, but for purposes of this demo, we will use only 2 of them. And we'll choose the Premium service level for this pool. Next, we need to enter a capacity, select the VPC, and remember this must be peered beforehand. We don't need any connections to Active Directory, so we'll deselect that, and then we'll give it a label. Once the storage pool comes up, we'll create the Flex storage pool using the same methods. So hit Create, give it a name, we'll choose that same location, and choose the Flex service level with zonal availability, and we'll use the same zone as the cluster, which is A, put in the capacity and the connection, deselect the Active Directory, and then give it a label. So after some time, that storage pool comes up, and we will install NetApp Trident on the cluster. Going to our terminal, this Helm command will install Trident as well as the Trident namespace. So after a few moments, that all looks up and running. So the next step then is to load the backends. This will, so to speak, connect and authorize Trident to use the storage pools we just created for new volumes requested by the Kubernetes persistent volume claims. So if we look at the backend file for the Premium service level, we can see the location is there, the service level which is in the storage area, and even the specific pool we want to use, although specifying a specific pool is not necessary. We can also see it needs credentials to authorize the volume creation, which we'll install in a moment. The file for the Flex service level is very similar, only it's pointing out characteristics of the Flex storage pool we just created, using the same set of credentials. So next, we're going to go ahead and create that secret with those credentials. And then we'll also create both of those backends. One for the Premium service level and one for the Flex service level with zonal redundancy. And by doing a kubectl get TBC, we can see that both backends are there and bound. So we are good to go. So last but not least, we will need to create some storage classes to use. So this is the file for the Flex storage class. Now keep in mind, one of the storage classes that come installed with GKE was already marked as the default. So I did remove that, so we can mark the Premium storage class the default. If the storage class is not marked default, you can still use it by specifying which storage class to use in the PVC, but marking one default might make things easier. So let's go ahead and apply both of those storage classes. And now when we do a kubectl get SC, we can see we have both of our storage classes there. One for use with the Flex service level and one for use with the Premium service level. So now you can choose which performance level you need based upon the Kubernetes application you intend to deploy. So for purposes of this demo, I will deploy a 3-pod deployment of Nginx. So looking at that manifest, we can see the service, the deployment, in which the pods will use the Nginx PVC claim, persistent volume claim, and then the PVC itself, where we are telling it to use the read-write many access mode, which means that all pods will be able to access the volume and a volume size of 10 gig. And we can also see the storage class denoted here, so this volume should come up in the storage pool with the Flex service level. So let's create the Nginx namespace, and we'll deploy this YAML file there. So after a little bit, we can see the pods are almost all deployed, And if we look at the PVC, it's already bound to a persistent volume that has RWX access mode. Of course, the PV is there as well. And let's keep in mind the name ends in 2A9. So if we go back to Google Cloud NetApp Volumes console and into the volumes, that volume has already been created in the GKE Flex storage pool, as we expected. It's 10 gig, as we specified, and the name is the same as what we saw in the PV ending in 2A9. So now going back to the terminal, we'll install another application called Odoo via a help chart. In this case, I will not specify a storage class to use, so it will use the default, which is the premium service level. It will take a little while to install all of those components, but after they're up, we can check out the PVCs that are there. They're also bound to PVs. In this case, the storage class is GCNV Premium K8S with access mode read-write once. So it should be in the premium storage pool. So back on NetApp volumes, 2 more volumes showed up in the GKE premium storage pool as we expected. So last but not least, let's take a snapshot from Kubernetes. Now this could also be done via the console or API, but we'll show doing it from the cluster, similar to how this could be built into an automated workflow. So first, we need to install a snapshot class to use with Trident. So this is a sample manifest of what that looks like. So let's create that. Next, we need a manifest to create the snapshot itself, which this manifest can do. And you can see it calls out the PVC from Nginx. So all we need to do is create or apply that, and we will have a snapshot of that volume. If we take a look, we can see it's not ready yet. So we'll try again right away, and now it is. Of course, we could do this for the other PVCs as well, completely independent of the service level. So back on the console, go to the volume, and then select snapshots, so we can see that snapshot. If we ever needed it, we can also use Trident to create a PVC from that snapshot to get that data into another application, or for recovery or even testing purposes. And of course, you can always take snapshots directly from the console. So now you can get great enterprise level reliability and performance for your stateful applications for GKE with Google Cloud NetApp Volume. Try it out and learn more using the URLs below. Thank you for watching and have a great day.